Welcome to the DIY Honda Garage channel. This troubleshooting guide is designed specifically for diagnosing and repairing DTC P0171, which indicates that the fuel system is running too lean in Honda Accord models from 2012 through 2017. The document emphasizes the importance of documenting all freeze frame data and onboard snapshots before proceeding, as clearing codes too early can erase valuable diagnostic information. It advises inspecting for aftermarket modifications that may influence fuel system readings, as these can impact diagnostic outcomes. Multiple related DTCs, such as those involving fuel pressure sensors, sensors for MAF, MAP, AF, and HO2S, as well as EVAP system codes, should be considered during troubleshooting. Correct interpretation of the diagnostic process involves verifying if the fuel mixture is truly lean under specific engine conditions, starting from engine idle and progressing through component inspections and testing. The guide provides a structured step-by-step approach, including verifying sensor readings, inspecting for debris, checking for component damage, and confirming system leaks. Ultimately, final verification involves replacing faulty components, such as fuel injectors, sensors, or the fuel itself, and ensuring system parameters return to normal levels, thereby restoring engine performance and emissions compliance. This step advances diagnosis by evaluating the high-pressure fuel system, which delivers fuel to the injectors at regulated high pressure. By turning the ignition off and then on, and clearing existing DTC codes with the HDS, you prepare for a fresh system diagnosis. The engine is started and held at 3,000 RPM until the radiator fan activates, then return to idle, simulating previous testing conditions. Using the HDS, the technician performs a fuel pressure test and checks whether readings are within specifications designated as norm. If the pressure is proper, the high-pressure fuel system is operating normally. If not, it indicates potential issues with the fuel pump, pressure regulator, or injectors. This diagnostic step provides valuable insight into fuel system health, essential for resolving lean running conditions caused by fuel delivery problems. If previous diagnostics suggest fuel supply issues, the next action is to replace the fuel with high-quality, known good fuel after draining the tank. This process isolates fuel contamination or poor fuel quality as a potential root cause for the lean condition. After refilling, the vehicle is restarted and driven under the same conditions that triggered the high AFFB reading. The technician monitors the fuel trim parameter via the HDS to determine if the lean condition persists. If the high trim value remains, the issue is not related to fuel quality, and further component testing is necessary. However, if the trim improves, indicating that contaminated fuel or other fuel quality issues were the cause, then the fuel replacement is validated as a successful correction step. This step tests for vacuum leaks in the intake manifold and related system components, which can cause unmetered air to enter and create a false lean condition. You disconnect the intake air duct from the air cleaner housing and attach a smoke machine or OTC Leakmaster evaporative emissions system tester to introduce smoke into the intake manifold. As smoke escapes from cracks or loose connections, the leak is identified. Common leak sources include the intake manifold gaskets, throttle body gasket, vacuum hoses, and air ducting. Once identified, these leaks are repaired or sealed. Ensuring a sealed intake system is vital because unmetered air bypasses the sensors, leads to incorrect fuel trims, and can cause persistent lean issues that are unrelated to fuel delivery or sensor failure. When all other causes have been ruled out, faulty fuel injectors can be the root of the lean condition. You turn off the engine and replace the fuel injectors with ones known to be functioning correctly, ensuring compatibility with the vehicle model. After installation, engine startup and the same driving conditions are performed to test whether the high fuel trim issue persists. Monitoring the AFFB reading during this test is critical. A return to normal indicates that the injectors were causing the lean condition. Conversely, if the issue remains, further diagnosis should consider other potential causes. This correction step addresses direct fuel delivery issues that could be subtly causing a lean environment, impacting overall engine performance and emissions. The final diagnostic step involves replacing the air-fuel ratio sensor, Sensor 1, which directly measures the exhaust gases to determine the mixture's richness or leanness. You turn off the ignition and remove the existing sensor, installing a replacement sensor known to be good. After restarting the engine, you perform the driving test under similar conditions to observe if the fuel trim improves. Monitoring the AFFB value with the HDS indicates whether the sensor was faulty. If it was, replacing it should correct the lean issue. If the problem persists after replacement, more extensive diagnosis might be necessary, including PCM substitution. This process ensures that the sensor providing critical feedback to the engine control unit is functioning properly, enabling proper fuel mixture regulation. The final step involves confirming that all previous repairs have successfully resolved the lean condition. You reset the powertrain control module, PCM, using the HDS and perform an idle learn procedure as prescribed, which recalibrates the fuel and air maps. The vehicle is then operated under the same conditions that previously caused the high AFFB reading, monitoring the parameters in real time. The key indicator of successful repair is that the AFFB, or short-term fuel trim, returns to normal levels below the threshold of 1.33. When confirmed, this signifies that the root cause of the initial DTC P0171 has been addressed, restoring proper engine operation, fuel economy, and emissions compliance. Preventive maintenance is vital to avoid recurrence of lean fuel system issues. Regularly inspecting hoses, connectors, and sensors ensures early detection of potential leaks or damages. Using high-quality fuel conducted at service intervals minimizes contamination risks. Periodic checking of vacuum hoses, intake manifold gaskets, and sensors maintains system integrity. Accurate sensors, calibrated and clean, contribute to precise fuel control, optimizing engine performance and reducing emissions. Following this comprehensive troubleshooting and maintenance regimen helps extend component lifespan and keeps the vehicle running efficiently in the long term. In conclusion, diagnosing and repairing DTC P0171 requires a systematic approach that includes initial verification of the lean condition, analyzing stored data, inspecting physical components for damage or leaks, and testing sensors and fuel pressures. Each step builds upon the previous one, ensuring comprehensive coverage of potential causes. Proper documentation, adherence to procedures, and final verification are critical to confirming resolution. Replacing sensors, injectors, or fuel as needed ensures the engine receives the correct air-fuel mixture, restoring performance and complying with emission standards. Consistent preventive maintenance supports long-term vehicle reliability and helps prevent future issues related to fuel system integrity. The initial step involves verifying whether the fuel trim indicates a lean condition during engine idle. You start the engine and let it idle without load, ensuring the automatic transmission is in park or neutral. or the manual transmission is in neutral. Using a Honda diagnostic tool, such as the HDS, you check the specific parameter, AF/FB, or short-term fuel trim. The acceptable threshold for this parameter at idle is less than or equal to 1.33. If the value exceeds this threshold, it suggests the engine is running lean, prompting further investigation. If the reading is within normal range, the issue may be non-fuel related or intermittent, and the system is considered normal for now. Accurate readings at this stage are critical because they set the foundation for all successive diagnostic procedures, focusing on whether the fuel mixture problem exists during idling conditions. The second step involves analyzing the onboard snapshot data captured when the AF/FB state fuel trim was at its highest point, which indicates the worst lean condition recorded during driving. You review parameters such as engine speed, vehicle speed, the relative throttle position sensor, and accelerator pedal sensor values during this snapshot. After recording these parameters, you drive the vehicle under similar conditions to those stored in the snapshot, ensuring that your environment matches. While driving, the technician uses the HDS to monitor real-time data, especially the AF/FB value. The goal here is to determine if the lean condition persists under actual operating conditions matching those in the stored snapshot. If the fuel trim remains above the threshold during these conditions, it confirms a persistent lean condition requiring further investigation. This analysis helps differentiate between intermittent and consistent issues, providing a clearer picture of the root cause. Next, you inspect the mass airflow MAF sensor and intake air temperature IAT sensor for contamination, which can impair sensor accuracy. Turning off the ignition ensures safety and prevents electrical damage. You carefully remove the MAF sensor IAT sensor from its mounting location, usually situated along the intake ducting near the air filter box. Once removed, you visually inspect the sensor element for lint, bugs, or other foreign objects that could obstruct airflow readings. If debris is present, you clean the sensor using appropriate methods such as vacuuming or special sensor cleaning solutions. Once cleaned, you reinstall the sensor properly and proceed with the next diagnostic steps. A dirty or damaged MAF sensor can falsely lean out the fuel mixture reading, so ensuring its cleanliness and proper function is essential for accurate diagnosis. The fourth step involves a visual inspection of critical intake components for disconnections, cracks, or damage that could lead to unmetered air entering the system. Key components include the crankcase breather hose, the air cleaner housing, intake air duct, oil cap, and dipstick. Disconnected or damaged hoses and components can introduce additional air into the intake, creating a false lean condition in the fuel mixture. You systematically inspect each part, looking for signs of wear, cracks, or loose connections. Any damaged parts are repaired or replaced as necessary. Maintaining the integrity of the intake system ensures accurate sensor readings and proper air-fuel mixture, essential for diagnosing whether the lean condition stems from leaks or other systemic issues. In this step, you evaluate the brake booster system, which relies on vacuum pressure from the intake manifold. With the engine running at idle, you pinch the vacuum hose connected to the brake booster. While pinched, you monitor the AF/FB ST fuel trim parameter through the HDS. If the fuel trim remains above 1.33 during this test, it indicates that the brake booster vacuum hose and the booster itself are not leaking. Conversely, if the fuel trim drops below the threshold, a leak exists within the vacuum system. A leak here can cause unmetered air to enter the intake, resulting in a lean condition. If a leak is suspected, Further inspection and replacement of the faulty vacuum hoses or the entire brake booster system are necessary to eliminate this potential cause. This step focuses on the positive crankcase ventilation PCV system, which routes crankcase vapors back into the intake for combustion. With the engine running at idle, you pinch the PCV hose and observe the fuel trim parameter through the HDS. If the fuel trim remains above 1.33, the PCV system is functioning correctly and no leak is present. If the trim value drops below threshold, a leak exists in the PCV hoses or the valve itself, potentially allowing unmetered air into the intake manifold. Repairs involve inspecting, cleaning, or replacing PCV hoses and components to restore proper positive crankcase ventilation. Ensuring the PCV system is sealed and functional prevents false lean readings caused by unmetered air infiltrating the intake, thus maintaining accurate fuel mixture control. This step involves a precise test of the mass airflow sensor's output at a steady 2,500 RPM. First, the engine is started and raised to 3,000 RPM to ensure the radiator fan activates, indicating operational engine temperature above 158 degrees Fahrenheit. Then, with the accelerator pedal held steady, you check the MAF sensor reading on the HDS, expecting a value between 6.5 and 9.1 grams per second for automatic transmissions, or 5.5 to 7.7 grams per second for manual transmissions. If the reading falls within these ranges, the MAF sensor is considered functioning correctly. If not, the sensor may be cracked, damaged, or improperly installed, leading to incorrect airflow measurement and a false lean condition. In such cases, replacing the MAF or IAT sensor is recommended, after which system tests should be repeated to confirm resolution. The 8th step involves measuring fuel pressure on the low-pressure side of the fuel system, which supports the fuel delivery to the engine. The vehicle should be operating under conditions where the AF/FB star fuel trim exceeds 1.33, indicating a lean condition. Using specialized tools, you connect a fuel pressure gauge to the fuel rail or test port and verify if the pressure is between 390 and 440 kilopascals, or 57 to 64 psi. If the pressure falls within this range, the low-pressure fuel system is functioning correctly. If not, the fuel pump, fuel filter, or associated regulators could be faulty, necessitating component replacement to restore proper fuel delivery. An accurate fuel pressure measurement is critical for diagnosing fuel supply issues that may cause or contribute to a lean mixture problem. Please like and subscribe to the channel. See you next time.